about expansion and contraction and read this background information together. Did you know not everything we observe has the properties of matter? Light does not take up space or have mass. Neither does sound. When you turn on a lamp or stereo and fill a room with light or sound, the room does not become heavier. Light and sound are forms of energy, and like all forms of energy, they do not have mass or volume. With this in mind, make a prediction about whether the mass of an object changes when it warms or cools. That is, when its thermal energy changes. So now we'll read about expansion and contraction. As materials warm up, the particle model of matter says that their particles move faster and spread apart. We expect substances to expand, increase in volume, as their temperature rises. Falling temperature means that average particle motion is slowing down. It seems logical to expect substances to contract, which means to decrease in volume as they cool. You can check those predictions by observing the behavior of common pure substances. A pure substance is a type of matter that is made of only one kind of particle. On Earth, a pure substance may exist as a solid, liquid, or gas. These are the three states or phases of matter. Gold, oxygen, and water are examples of pure substances. Examine the illustrations to review the key characteristics of each state. So these are the three states of matter. These are the three states of actual water. So here's ice, which is a solid, liquid, which is water, and steam, which is a gas, but they're all H2O. All right. In the solid state, materials keep their shape and size. Solids like ice have a definite shape and volume and cannot be compressed into a smaller space. In the liquid state, materials have a definite size, volume, but no fixed shape. Liquids like water settle to the bottom of their container and take its shape. Liquids cannot be compressed. Gases have no definite shape or volume. They expand to fill all parts of their container and can easily be compressed into a smaller space. Many gases cannot be seen. For example, the space just above a kettle spout is filled with invisible water vapor. You can look at the picture above here. Can't see it very good here. You can see it pretty good here. As the vapor, water in the gaseous state, rises and cools, it forms a cloud of tiny drops of liquid water. Civil engineers have to think about thermal expansion and contraction when planning roadways, sidewalks, and bridges. Imagine that a builder or a civil engineer has been invited to speak to your class. Write 5 questions that you would like to ask this person about engineering as a profession. Make sure your questions are clearly worded and they will help you find out what you want to know. So here's a picture of civil engineers. They're actually people who build bridges and sidewalks, right? And roadways. Expansion and contraction of solids. This is the table of expansion and contraction of solids. So it's the material and how long it is at negative 100 degrees Celsius and how long it is at positive 0 degrees Celsius. And then how long it is at 100 degrees Celsius. So you can see that as it's cold, it's shorter than it is when it's warm. Same thing with steel. It's shorter than when it's warm. Aluminum is shorter when it's cold than when it's warm. It talks about brass, copper, glass, and Pyrex. Here's the explanation. Expansion and contraction of solids. The lengths of solid bars of different materials can be measured at different temperatures using very precise equipment. Table 1 shows some of these measurements. You can see that the changes in a 100 centimeter long bar are very small. If the bar were twice as long, however, the changes would be twice as large. In a very long structure, such as a bridge or train track, the small changes can add up and become very important. Here's an activity that you can do to see how substances expand when they're heated or contract when they're cooled. All right. When substances are heated and cooled, changes in size can be small and easy to overlook. And then it gives you an activity to do about making a prediction and then checking it in an activity. And what you do is you basically put a wire between 2 posts and you heat it and cool it to see what happens to the copper wire that is stretched between the two posts. And then there's another ball and ring lab that you can do. We don't have the materials for this, but you can easily fit this ball through this ring when it's cool, but then if you heat it up, it will expand and you will not be able to pass it through the ring because the metal has expanded. So these questions actually ask you to apply what you have learned about telephone wires and explain why objects contract and expand when they're heated.